All right. So we've got this cart up here, and notice it's not moving to begin with, right? And it's going to roll down this hill, and the question is, what's its speed at the bottom, right? So there could be some mention of a force times a distance, but I don't see that here. There could be potential energy to begin with, and I think that's what we have, right? It could be moving to begin with, but it's clearly not, right? There could be a spring compressed, right? Okay, but I don't think it's not moving. There's no mention of any springs. There's no mention of a force. So I think all we have here in this situation is just mgh, right? And then at the bottom, here's this thing. It's going to be moving at some speed. Its wheels are somewhat conjectural, but the rest of it. And there's no mention of a force that slows us down. There's no potential energy because it's at the bottom, but it is moving, right? So there's going to be kinetic energy. And again, there's no mention of springs, right? 1/2 kx squared. There's no springs, right? So this is just a one-to-one. This is potential turns to kinetic. So we've got mgh turns into 1/2 mv squared, right? Notice that the mass cancels, which is very handy. So we're just going to plug in numbers. 9.81. Our height is 2.15 equals 1/2 v squared. So I'm going to go 9.81 times 2.15 times 2, and that's what v squared is, right? And then I'm going to square root that. So 6.49 meters per second squared. Just meters per second, sorry. Not squared.